Have you ever wondered what the absolute maximum an entire economy can produce? It's like one of the biggest questions in all of economics. And today, we're not just going to answer it, we're going to build the exact tool economists use to figure this out, and we're going to start with just 3 people. All right, so how do we solve this puzzle? Well, we're going to create a super simple, tiny economy with just 3 people. And by seeing how their unique skills fit together, we're going to uncover this really powerful secret about how specialization, doing what you're best at, unlocks the true potential of any economy, whether it's our little one or a massive global one. Okay, first things first, let's meet the crew. In our simple little economy, we've got 3 workers, and they can produce 2 things, oranges and milk. Now, the key thing to remember here is that they're not all the same. Each one has a totally different talent, a different specialty. Now, here's where it gets interesting. The story isn't just about the total numbers, it's all about the ratios. So take a look at worker A. They can make 16 tons of milk, which is exactly double the 8 tons of oranges they could make. Then you've got worker B, who's an absolute milk-making machine. We're talking 5 times more milk than oranges. And finally, there's worker C, our jack-of-all-trades, with a simple 1-to-1 trade-off. These differences, this is the engine that's going to power our whole economy. Okay, so with all these different skills on the table, how in the world do we decide who does what? I mean, who's actually the best at making oranges, and who's the best at milk? To figure this out and really unlock our economy's potential, we can't just look at who can pump out the most. Nope, we have to start thinking like an economist. And you know what that means? It all boils down to one absolutely crucial idea: opportunity cost. See, the real cost of anything isn't about the money. It's about what you have to give up to get it. So the question becomes, for every single ton of oranges we decide to make, how much milk did we not make instead? The person who gives up the least amount of milk, well, that's our true oranges specialist. Okay, enough theory. Let's actually put this into practice. We're going to calculate the opportunity cost for each of our workers, specifically the cost of producing just 1 more ton of oranges. And that price we're talking about, it's going to be measured in the tons of milk they have to give up to make it happen. And look at that. The math just lays it all out for us, crystal clear. Worker C is our most efficient orange producer, hands down. They only give up 1 ton of milk for every ton of oranges. Worker A is in the middle, but worker B, wow, it costs them a whopping 5 tons of milk just to make 1 ton of oranges. So yeah, definitely not our orange guy. But here's the cool part, the flip side of the coin. The person with the highest opportunity cost for making oranges, that's worker B, right? Well, that automatically makes them our most efficient, our absolute best milk specialist. Why? Think about it. It's incredibly expensive for the economy to have them do anything but make milk. So there we have it. We've got our specialists ranked for both goods. Okay, now for the really fun part. We're going to take this new ranking of ours and actually build a visual map of our economy's true potential. And this map, it has a name, the production possibility curve. It's going to show us every single efficient combination of oranges and milk that our little team can possibly churn out. So we're going to start at one extreme end. Let's imagine our economy puts every single person, all 3 workers, on orange duty. Nothing but oranges. We just add up what they can make. 8 plus 4 plus 10. That gives us a grand total of 22 tons of oranges. And obviously, 0 tons of milk. That's our first point on the graph. Let's plot it. But of course, an economy that only makes oranges isn't very realistic. People want milk. So if we decide we need some milk, we have to make a smart choice. We don't just pull a random person off the orange line. No way. We send our best milk specialist first. And who was that? Worker B. Now, as they say, there's no such thing as a free lunch. When we move worker B over to making milk, we lose those 4 tons of oranges they were producing. But just look at what we get in return. A huge gain of 20 tons of milk. That right there, that is the power of using your specialists wisely. And just like that, we have our second point for our curve. This is a new, totally efficient production point for our economy. 18 tons of oranges and 20 tons of milk. We've made our first strategic trade-off, all thanks to specialization. All right, let's keep this ball rolling. We want even more milk. So who's up next? Our second best milk producer, worker A. So we move them over. The trade-off this time? We lose 8 tons of oranges, but we get another 16 tons of milk. So our new sweet spot is 10 tons of oranges and 36 tons of milk. Okay, last move. To squeeze out every last drop of milk possible, we have to move our final worker, C. And notice how the trade-off is getting way worse now. We're giving up a full 10 tons of oranges, and remember, C is our best orange producer, just to get 10 more tons of milk. This brings us to the other extreme end of our graph, 0 oranges and a grand total of 46 tons of milk. So let's connect all those dots we just plotted. What we've just created is the production possibility curve, but I want you to look really closely at its shape. See how it's bowed outwards? It's not a straight line. And that curve, that specific shape, is not an accident. It's telling us something really, really important about how economies actually work. See, if all our workers were just clones of each other, this graph would be a perfectly straight line. The trade-off would be the same every single time. But our curve is bowed out, and the reason why is that as we shift more and more people to making milk, the trade gets more and more expensive. Think back. That first big chunk of milk, 20 tons, only cost us 4 oranges. But that last little bit, those final 10 tons of milk, that cost us a full 10 tons of oranges. This, right here, has a name. It's called the principle of increasing opportunity cost. And it's a fundamental rule in economics that exists for one simple reason. People and resources are not all the same. They're not interchangeable. We moved our best milk producers first, which was cheap. But to get those last few drops of milk, we had to pull our best orange producer off the job. And that was a huge sacrifice. The cost just keeps going up. And there you have it. That's how you build a production possibility curve right from scratch. It's so much more than just a line on a graph, isn't it? It's a visual story about scarcity, about making tough choices, and about the absolutely incredible power of specialization. And it leaves us with a final kind of mind-blowing thought. If this is the economic power we can unlock with just 3 different workers, just imagine what that curve looks like for a global economy of 8 billion highly specialized people. What is our true collective potential?